sunset. All right, welcome, ladies and gentlemen. I think yep, okay, I've got audio. Good, that's all that matters. So we're looking at last night's homework. We're talking about sigma notation in the nth term. We're on page 798, and we're trying to write this. This appears to be an infinite sequence, so I do want to point that out. Let's see, looks like I've got a little, all right, now I've got less lag. So I've got to figure out what is the nth term for this, is what I've got to figure out. So it appears as though the nth term, 4, 9, 16, 25, those numbers should be pretty familiar to you. Those look like perfect squares. And if n is starting at 1, well, 1 squared is not 4. So it looks like that might be an n plus 1 squared, if n is starting at 1 for you. But there are multiple ways of representing sigma notation for these. So 1 plus 1 squared is 4. 2 plus 1 squared is 9. 3 plus 1 squared is 16. So, okay, so that appears to be working. But now I've got to account for this alternating sign. So what do I multiply that by? -1. And I raise it to some n. And when n is even, it's positive. When n is odd, it will be negative. Now, it looks like I've got to offset this a bit.
If you use n equals 2 to start out,
yeah.
you need the plus 1.
Yep, we'll get there in a moment. I'll probably do that modification. But yeah, so it looks like in order to get n to be even, I'd have to kind of add 1 to it so that it starts with a positive instead of starting with a negative. So my sigma notation would look like this. So sigma, the sum of n equals, I'm going to define it according to this first, and then we'll do the modified one. So starting at n equals 1 to infinity, because this list ends in an ellipsis, so it's going forever, I would have -1 to the n times n plus 1 all squared. Nope, sorry, n plus 1 here for the exponent, isn't it? Yep. And then, as the student was saying, since both of these happen to be n plus 1s, maybe it's better to start with n being 1 more than what it is. So an equivalent one would be have n start at 2. Don't forget that you'd have to also increase infinity by, oh wait, I'm just kidding. Infinity's still infinity. Classic. So this would be -1 to the nth and times n squared, right? Because n starting at 2, 2 squared is 4, and -1 to the 2 is even, so positive, and it seems to work out. So either of these answers are good. This one, I agree, looks a little simpler, but some people are interested in always having n equal 1, so I'm fine with either. So let's look at another problem. Did someone mention 37 earlier? Let's see if I can get this to focus, enhance, playback. Could you zoom in right there, please? There we go. Oh, wow, 37. That is interesting. Ah, nope. All right. There we go. Whew, classic. Delete. Why do I even have that as an option? Well, I guess if I'm like dragging this around, I might be like, oh, I copied it in the wrong spot or something, but I can also just hit the delete key, but I suppose with the wirelessness of my little tablet, I can maybe not always be at my laptop. So let's see. How would you describe this series? What like if you had to classify it, what kind do you think this would be? Dividing by 2.
Going down exponentially.
Dividing by -2. I could also say multiplying by -1/2 repeatedly. So what kind of series is that? I think this is just straight geometric, isn't it? Like r is just -2, or what? Sorry, -1/2. I think it's a pure geometric, but And since it's alternating nature, I don't believe this would have a sum because it would kind of be bouncing back and forth.
No.
Might have, no, it might.
It would have a negative sum.
Yeah.
Yeah.
It might. Yeah.
Yeah, here's the answer I got.
But anyways, we're doing a sigma notation here, so we don't actually have to worry about that stuff. But the nth term, what's the nth term going to be? What do you got?
A sub n equals parenthesis negative 1 parenthesis to the n power times 2 to the 6 minus n power. That's what I have. The book has really different.
Okay.
The book says negative 1 to the n plus 1 times 32 over 2 to the n. Where n starts at 0.
Times 32 to the 2 to the n?
Over 2 to the n.
Oh. Well, or I could make that just 2 to the negative n, I suppose. Yeah, there's definitely more ways to do it. It looks like their approach was they were more directly using our formula for a geometric. A sub n, wasn't that equal to a1 times r to the n? Was it minus 1? I think so. Yes, yeah. So I think they were trying to more directly relate it, so that's why they have the 32 there. Yeah, divided by 2 to the n or 2 to the negative n, whichever way you'd want to think about it. Technically, let's actually take theirs and modify it. 32 is the same as 2 to the 5th?
Wait.
Nope.
Actually, it's to the 5th. Yeah, it is.
Yeah, because they're using the n plus 1 version, remember?
So they're using, yeah.
And then if I wanted, I could combine those. How do I deal with that? How do I simplify that?
5 minus n.
Right, add the exponents, so 5 minus n or negative n plus 5, whichever you'd want to think about it. So for theirs, or for this variation of it, I would say you could have sigma of n equals 1. No.
And it has to equal 0 for that.
N equals 0?
Yep.
Yeah, interesting. To infinity, because it's going on forever. And negative 1 to the n plus 1 times 2 to the 5 minus n. Now, yeah, so, right. So if n is 0, 5 minus 0 is 5, 2 to the 5th would be 32, and it would be negative. Yep, okay, so that works out.
But if you did it n equals 1, then you would have negative 1 to the n times 2 to the 6th minus n.
Yeah. And technically, you don't even need this negative 1 to the n so much. I think we'd be able to even incorporate the minus sign within the 2 somehow if we were really careful. You could have actually set it up as,
Yeah, you could have put the negative in there.
Negative 32 times 2 to the negative n.
You could have said
This is
negative 2 to the 6th.
negative 2 to the 5th. Yeah. I'd have to be a little careful.
You have to put negative 2 in parentheses.
Let's see. 2 to the negative n. Oh, I'd have to offset it. I think there is a way you'd be able to combine it, but it'd be a little bit funky. But you have a solution?
Yeah, if you just made 2 negative.
This too?
No, in the one above. You got rid of the negative 1 to the n.
So you're saying an alternative would be sigma of n equals 1 to infinity of just negative 2 parentheses 6 minus n?
Yep. Because anything 1 that would be 5 and that would make it negative.
Yeah.
And then 4 would be positive.
Right. That's what I was worried about, was just the sign lining up with the number there. Well, that's what I kind of did over here. This would have just been 1/2 to the n. Yeah. So there are multiple ways of doing this. What did you have an answer you'd submit as a potential that's different than one of these, or? Yeah. And yeah, like technically you could even have kind of left it in this form and just taken this and plugged it in down here. But yeah, interesting stuff. How about one more, shall we? 23? Well, that would have just been a matter of plugging those in. So 3 factorial, 4 factorial, 5 factorial, 6 factorial, 7 factorial. I would recommend calculating those using a graphing calculator, or actually it even works on other calculators. But if you hit the, so if I want to calculate 5 factorial, here, actually let me clear this out. Clear. So 5 factorial, I would hit the math button here and go over to the PRB screen, probability, and factorial button's hiding there. And on the smaller calculators, there's also a PRB button, I think, that has the factorial hidden within there. So yeah, so it's just a matter of calculating that out. Doing it by hand or having to do 7 times 6 times 5 times 4 times 3 times 2 is a pain. So, yeah. And then you just add them all together. Did we end up doing some of these lower ones? We did. Let's look at 40. I think 40's got a good summary of concepts. I wish they had more problems that didn't end in infinity, because I find it interesting to find the stopping point for n. I think that adds a layer of complexity. So for this problem, let's do this together right now. You don't necessarily have to write this down. But let's see if we can together figure out the nth term. So 3, 8, 15. The next one would be 24 for the numerator pattern. I don't know if that would help. Now excluding you, since we talked about it. Wait. I think it's the squares minus 1. Right, 4 squared minus 1, 3 squared minus 1. Sorry, I said 4 squared. 2 squared minus 1, 3 squared minus 1, 4 squared minus 1, 5 squared minus 1. So I think the numerator, doing this piece at a time, I think n squared minus 1 would be that. How about these numbers here? All right, so you recognize factorials there in the 2, 6, 24, so it looks like an n factorial. That might have to actually be n plus 1. Yep. Okay.
N plus 1 squared minus 1. N plus 1 all over n squared. The n, I think it's just n factorial if we're going to have it start at.
Yeah. Usually my first go is to have it with n equals 1 for the starting one. But I agree, Zeb, that it would be simpler to do it the other way. And then how about 9, 27, 81? 3 to the n?
No. 3 to the n plus 1. Yeah.
Okay. So yeah, with all of these n plus 1s, I think we'd agree having sigma start with n equals 2 would make the most sense. So n equals 2, and I'll just change all of the n plus 1s to just straight up n. So n squared minus 1 over 3 to the n times n factorial. And this one's stopping at infinity. So, yeah, yep. Yeah.
If I get a formula that has all those n plus 1s, I can just put in n equals 2 and just drop all the 1s.
Yeah, you can simplify it like that. I find it nice to be able to do that. Yeah. Mhm.
So with starting at 2, if you had done that by doing n minus 1 for some odd reason, you start at 3.
Yep. Yep. And that's what's I find this stuff interesting because I think we all might spot the patterns differently at our first coming across it, and then trying to find the most efficient solution I think is nice. And that's actually I said this actually in my first period class today, but mathematicians often the first thing they care about is accuracy. Can they find something that is the right answer? And then the second thing they care about is efficiency. Can they do it in the fastest possible way? And then the third thing they care about is elegance. Can they do it in a way that is mathematically beautiful and just has a degree of appreciation, almost like poetic or artistic solution to it. But yeah, so that's what typically we'll find something accurate first, and then we do the efficient. I don't know if there's any elegance to be found in this just yet, but it is certainly I think we agree that this is more efficient than having n start at 1. So anyways, all right, goodbye Internet. It's quiz time.